Hello everyone. Today we will present about vehicle plate scanner from Wallbright Group. We will be presented by Mr. Tanin, Mr. InTouch, and Mr. Tulatorn. So, why we use this method? Our projects aim to detect and read car license plates. The aim is not simply to detect, but also transform the detection license plates to directly face the screen. The way that the license plate will be detected is by using the approx polydp function. This is a function used to detect the vertex of a contour. If the approx polydp function detected 4, then it is likely that the object detected is the license plate. While there are some limitations, which will be discussed in the improvement section. The approx polydp function was chosen instead of using the control area because, firstly, Thai license plate are the white color. This is a problem because when the photo of license plate is taken, there are a lot of white colors in it. This makes it difficult to try and isolate the license plate from all the other objects in the photos. Secondly, the photos are not taken at exactly the same angle. This means that the size, or rather, the contour area of the license plate can vary quite significantly from one sample to another. Hence, approx polydp was discussed to be better alternative. This is the flowchart, and this flowchart is only the overview of what we did in this project, which will be further explained in the coding section. But at first, I will explain a little bit about flowchart. So from the start, we import the independence, and then we input the image. Then we change the image to RGB or red, green, blue, and gray. We bilateral filter and canny. Find contour and get location from contour, and then we create the mask over the license plate. After that, we wrap the license plate and input the license language. Then read the text from license plate using the easy OCR. That is the end of our progress. Now is the coding section, starting off with installing easy OCR packages. Easy OCR is used to detect and recognize the text on the license plate. This was important because we find the reading of license plates, which utilize machine learning to be outside the scope of the subjects. Then the various dependencies are important into the programs. The input image is imported using the CV2 read function. The image is then changed to both gray and RGB to get the outline of the image, or the canny. First, the noise in the image is reduced using the bilateral filter function. Bilateral filter function is used instead of other noise reduction methods such as Gaussian blue. Because the bilateral filter does not reduce the quality of the edge of the image, which will preserve the quality of the canny. Then the canny is found using the CV2. Often, the first threshold 30 and the second threshold is 200. These two numbers are chosen because after a few tires, the other arbitrary numbers, these two thresholds seem to produce the most consistent result.
After that, the contour are found from the canny image using the find contour function, specifically the retrieve tree hierarchy, which finds all the contour from all the hierarchy. Then the immaterial.grab contours and sorted functions are used to easily sort the contours from largest to smallest, with only the first 10 actually being remembered. This is because the small contours in the image are likely to simply be noises and are not actually needed. Next, the location of the contour for the license plate is found using a simple algorithm. First, an empty variable called location is created. This is to be used to store the location of the license plate. Then a for loop is created with the variable contour looping through all the contours from the previous function. The approx poly-dp is then used to find which of the 10 contours is a quadrilateral. This is because the approx poly-dp function is used to find the vertex, the corner of each contour, with the input number in the function specifying how fine the contour has to be. The higher the number, the finer the contour needs to be for the approx poly-dp to detect the corner. Once again, 10 is arbitrarily chosen because it produces the most consistent results. Now, to actually find the contours that correspond to the license plate, the len approx condition is used. The len approx corresponds to the number of corners in the contours. Therefore, to find a quadrilateral contour, the if condition is set to 4. Once the location has been found, in the testing program, a mask is created to cover everything except the license plate. This is simply used to check whether the location obtained is correct or not. However, in this program, after the image goes through the transform picture function, which is a created function used to warp the license plate to directly face the user. First, the function will receive the image and its location. The location will then pass through another function called order point function. This function is used to rearrange the inputted location to correspond to the top left, top right, and bottom left corner of the license plate. The width of the transform license plate can be found by finding the maximum values between these two values, the one in the void box here. The equation is used to find the distance between 2 points because we want to draw a right rectangular box around the license plate. And to make sure that the entirety of the license plate is covered, only the maximum values between the two widths will be considered. Similarly, the height of the transformed license plate can be found with this equation, the bottom white equation, where once again, only the maximum number between those two will be considered. The variable dst will then be created as a float32 numpy array. dst will be used to create the matrix M from the getPerspectives transform function, which will finally be used to warp the license plate towards the user. Lastly, the function transform picture will return the warped image back to the main program. Once the main program receives back the warped image, EasyOCR will then be used to identify what was written on the license plate. The language needs to be specified first, either TH for Thai or EN for English. Any other language that might be used. Lastly, the extracted text is printed along with the warped image as the final results.
To recap, the result of this project is the warp image and the extracted text from the image. We have also created a UI for ease of use. First, the image of the license plate need to be uploaded for the program to process. Then the license plate language need to be specified for the easy OCR to extract the text. Currently, there are only buttons for Thai and English because in our dataset we only have Thai and English letter license plate. So as you can see, this is the result from our code. Okay, so as previously mentioned, there are some problem with the approx poly-dp function is used. Because it is used to detect shape with 4 corners, the program can mispredict some other square things in the image that are not the license plate as seen in the presentation. Furthermore, if the contour of the input image is too fuzzy, it would not detect anything at all. A way to solve this problem could be to increase the contrast of the image before doing the bilateral filter and creating the canny. However, we have tried that and it did little to fix the problem. One of the possible fix that we did not do yet is to use machine learning to do a preliminary cropping of the image. so that only the area close to the license plate are left. Then this current program could be used to finely crop and warp the output image. We also believe that our UI website could be a little bit of use a little bit of work. This is because there are some occasional bugs when running the program, and it still looks somewhat empty. Overall, while imperfect, we believe that this project is a success and can be used as a stepping stone for us later in the future. Thank you for okay. Let me show you the our code. Okay, so this is our UI. Then I will put in a photo as a example. Okay, so as you can see, when we put the photo in, it will show in like this, and we need to choose the language of the license plate. When we push the button, it will show the picture of the car and the plate, which is not loading right now. Oh, wait. Hmm. Okay, so here it is. And as you can see, it will read out the license plate right here. Okay, so another example. So for this one, as you can see, it detect the other thing like the logo and not the license plate. So this is the part that we think that need to be improved. And yep, that's it. So thank you for listening to our presentation.